Okay, this is our solutions video for section 3.2. In section 3.2, we learned the product and the quotient rule. Quick review. The product rule says if we're going to take the derivative of a function times another function, we take the derivative of the first function times the second plus the derivative of the second function times the first. All right. The quotient rule says if we're going to take the derivative of a function divided by another function, the denominator squared goes in the denominator. Then from there, we get the denominator here times the derivative of the numerator minus the numerator times the derivative of the denominator. All right, those are our two rules. These problems usually involve quite a bit of algebra to simplify to get to the final answer. So we need to apply the rule in the first step. Typically, that's our first step. And then from there, we have to simplify. And that typically requires a significant amount of algebra. So in the homework, we'll start with the very first problem. The very first problem they asked us to differentiate was f of x equals, and we have x cubed plus 2x times e to the x. So this is our function f right here, and this is our function g here. So when we find the derivative, I'm going to go ahead and write everything out. We're going to follow this rule for the product rule because we have a product of two functions. So we're going to take the derivative, which many of us can do in our heads, but I'm just going to write it all out. We're going to take the derivative of the first function times the second function, so times e to the x, plus, now we take the derivative of e to the x, that's our second function, that's g, times the first function. And again, I'm just writing out all the steps on the first few. Now, this is a polynomial, so the derivative of that is going to be 3x squared plus 2, right? 3x squared, bring down the 3, take away 1. Here you have an exponent of 1, so 1 times 2 is 2, x to the 0. Now we keep the e to the x. We'll distribute in the next step. The derivative of e to the x is e to the x, and we're left with x cubed plus 2x. Okay, from here, it's going to be a marathon of algebra. Sometimes the algebra goes rather quickly. Sometimes the algebra takes a bit of time. Both of these functions are multiplied by e to the x. So before I distribute the e to the x here and distribute the e to the x here, I can factor out an e to the x. There's an e to the x factor here and an e to the x factor here. So if I pull that out, I'm left with 3x squared plus 2 here, plus x cubed plus 2x. Now there are no like terms in there. So if we're going to rewrite our answer, we would write it in descending powers of x. That's our convention. So we'd have 3x squared plus, x cubed plus 3x squared plus 2x plus 2. All right, so that's the answer to number 3. If we take a look at number 5, all right, number 5 is going to be our first quotient rule problem. 5 is e to the x divided by x squared. E to the x divided by x squared. Again, this is going to be our function f, our numerator, and this is going to be our function g, our denominator. When we take the derivative, the very first thing we do is we write down the denominator and we square it. And we'll clean that up. Then we copy the denominator here. we're going to multiply, and again, I'll write it out. We're going to multiply by the derivative of the numerator minus, then we copy the numerator, and we're going to multiply by the derivative of the denominator. So that's our first step for the quotient rule. That equals, we get an x squared. The derivative of e to the x is e to the x minus, we have an e to the x. The derivative of x squared is 2x. And all this is divided by x squared squared, x to the fourth. Now, what do we get here? Well, there's an e to the x and an e to the x in both terms. There's an x and an x squared, so we can factor out e to the x times x. That leaves us an x here. E to the x we factored out, the x we factored out, so we get minus 2. And on the bottom, we have x to the fourth. Now we have a factor of x to the first in the numerator and a factor of x to the fourth in the denominator. So that gets us e to the x times x minus 2 divided by x cubed. So that's our answer to number 5. Now, if we skip down to number 8, for example, again, I'm not going to do every single problem. If we skip down to number 8 is also a quotient rule problem. It says f of t equals, and we get 2t divided by 4 plus t squared. Now we can't simplify, right? We want to make sure that we can't simplify before we start. We always try to simplify, because if we can simplify this expression, well, it's going to make the derivative easier, but there's no simplification, nothing we can cancel here or anything. So we're going to find the derivative of this. Now we're going to follow our standard approach. We take the denominator, we write it right here, and we're going to square that. Now we are not going to expand that. We don't expand, remember, we don't expand the denominators typically when we work a quotient rule problem. We copy the denominator right here. We're going to multiply by the derivative of the numerator. And I know most of us can do that in our head, but I'm going to write it out for just 1 or 2 more problems after this, and then we'll just start doing the quotient rule. We want to make sure we establish the steps clearly. So denominator, derivative of the numerator, minus numerator, so that's 2t, times the derivative of the denominator. So that's going to be the derivative of 4 plus t squared. Now, if we simplify these, we have 4 plus t squared. The derivative of 2t is 2, minus, here's our 2t. The derivative of a product, remember, we take the derivative of the first term plus the derivative of the second term. The derivative of 4 is 0. The derivative of t squared is 2t. And down here on the bottom, we have 4 plus t squared squared. Again, we're not going to expand the denominator. So here we distribute. 2 times 4 is 8. 2 times t squared is plus 2t squared. This is going to be minus 2 times 2 is 4 t squared. And on the bottom, we have 4 plus t squared squared. 8. These are like terms, so we have minus 2t squared there. And we have 4 plus t squared here squared. And we can simplify that. We can factor out a 2, so we get a 2. And that gets us 4 minus t squared divided by 4 plus t squared squared. And we can factor this as the difference of 2 squares, but it's not going to simplify the problem. We're not going to be able to cancel one of those factors. So there's no reason to factor that. So we'll leave it as 4 minus t squared. Okay, so that's problem 8. If we move down to problem 17, all right, we'll take a look at problem 17. Problem 17, again, is expressed as a quotient, right? We have y equals, we have v cubed minus 2v root v all divided by v. And if we're not careful, right? If we're not careful, as over here, I pointed out we didn't have the opportunity to simplify. Here we do have the opportunity to simplify. If we go through some steps, some algebra steps here, we have v cubed here. This is minus 2v, and v, the root of v is really v to the 1/2, right? And we're divided by v. And if we do more algebra, we're not doing any calculus, we're just doing algebra, we get v cubed. This is minus 2 v to the first times v to the half. That's v to the 3/2, and we're dividing by v. Well, that's a common denominator. This can be rewritten as v cubed over v minus 2v to the 3/2 over v. Each of those can be simplified. V cubed over v is v squared. This is v to the first, so we subtract here, and we get minus 2, right? That leaves us a negative 2. V to the first into v to the 3/2 leaves us v to the 1/2. We don't even need the product rule to do this. We don't need the product rule or the quotient rule to do this problem. We can find the derivative just by using our power rule. The derivative of v squared is 2v. Here we have a minus 2. We bring down the half, right? We bring down the half. We take away 1, and we get v to the minus 1/2. So if we simplify, we distribute here. This is going to be 2v. This is 2 times a half. That's 1, and we get minus v to the 1/2. And that's a v to the negative 1/2. Now, here we have to start thinking about how to express our solution. The problem was written as a quotient. So we're expected to rewrite our problem as a quotient. We're expected to do some algebra here. So this is 2v minus 1 over v to the 1/2. But that's still not a quotient. That's a monomial minus a fraction. We need a common denominator. If we're really going to express our answer correctly, we need a common denominator. This is 1, so our common denominator is going to be v to the 1/2. So this is going to be 2v to the first times v to the 1/2. That's going to be 2v to the 3/2. And this is going to be minus 1. And then the last step, if we really want to be thorough and express our answer correctly here, this problem was not written with fractional exponents. It was written with radicals. So they expect us to give them an answer as a radical. So we have the square root of v cubed minus 1 all over the square root of v. And of course, the square root of v cubed is 2v root v minus 1 over the root of v. This is a correctly expressed answer. What we're expected to do is to provide an answer in the same format as the original problem. And we've done that here. The original problem was a compound fraction. So we've got that. We didn't leave it like this. We wrote it with radicals, and we got a common denominator. So that's number 17. Again, doing a little bit of algebra before you start sometimes eliminates the need to use the product rule or the need to use the quotient rule right off the bat. If we skip down to something like number 23, okay, 23 is one of those problems that when we write it down, we can be intimidated. I probably won't do the entire problem here on 23, not because it's difficult, it takes a lot of time, just because the beginning is really the important part. We have x divided by x plus c divided by x. All right, so what have they done? They've given us a complex fraction and they want us to find the derivative. Now, we don't have a rule for finding the derivative of a complex fraction. we have the derivative of just a fraction. So we're going to have to do algebra to simplify this. We're going to have to take this denominator, get a common denominator, right? Leave the numerator alone. The common denominator is going to be x. So we'll have an x. This is 1. 1 times x is x. X times x gives us an x squared. X goes into x 1 time. 1 times c is c. So we're left with x divided by x squared plus c divided by x. But now, of course, we can rewrite this. This is x over 1. So we can write this as the product of the numerator times the reciprocal of the denominator. That's how we divide fractions. And that leaves us x squared divided by x squared plus c. So we had to do a little bit of algebra at the beginning to get our fraction in the form of something we could actually take the derivative of. Now, if we're going to take the derivative of this, now we apply our quotient rule, because now it's written as a function divided by a function. And our quotient rule steps, remember how that works. We take the denominator, we just copy that down, we square it. We copy the denominator here. Then we take the derivative of the numerator, right? The derivative of the numerator. The derivative of x squared is 2x minus. We copy the numerator here. So that's x squared. We take the derivative of the denominator. The derivative of x squared is 2x. The derivative of a constant c is 0, so that's all we're left with. Now we distribute here. 2x times x squared is 2x cubed. 2x times c is plus 2cx. C is a constant. Here we get minus, right? Minus and 2x cubed. And on the bottom, of course, we're not going to expand this. Now, what is our numerator? Our numerator is 2x cubed minus 2x cubed. Those cancel. We get 2cx divided by x squared plus c squared. So in this problem, it started out looking rather threatening, but we did some algebra, got a common denominator, just broke out our algebra 2 skills there. And once we got a common denominator, and then we divided the two fractions to get rid of the complex fraction, we were left with just a normal fraction, numerator, denominator, and then we applied our quotient. That's number 23. All right, I'll skip down from there. On 27, all you're going to do there, it's a quotient rule problem. All you're going to do there is find the derivative. And then when you're done with that, you're going to find the second derivative. So you're going to find the derivative of the derivative. So you're going to do two derivatives. Problem 31 asks for the equation of a tangent line. So let's take a look at that one. We haven't done an equation of the tangent line problem in a while. So problem 31, they give us y equals 2x e to the x. They give us a point on that curve, 0, 0, and they want the equation of the tangent line that passes through that point. Now we know the equation of that tangent line is going to be y minus 0 equals the slope. The slope is going to be y prime, and that is going to be multiplied by x minus 0. So all we have to do is find y prime. We have to find the slope. Slope of the tangent line is the derivative. So we have to find the slope. So how are we going to do that? Well, this is a product of two functions. So the derivative here, we take the derivative of 2x, that's 2. We multiply by the second function, e to the x, plus we write down the first function, 2x. We multiply by the derivative of e to the x, which is e to the x, and there's our derivative. Now we have to evaluate that derivative at x equals 0. So we plug in a 0. So we get 2 e to the 0 plus 2 times 0 times e to the 0. 2 times e to the 0 is 2. 2 times 0 is 0 times e to the 0 is 0. So our slope is 2. So the equation of our tangent line through the point 0, 0 is y minus 0 equals 2, the slope of the tangent line. The derivative evaluated at 0, all the same thing, times x minus 0. So we get y equals 2x. Okay. So that's another one of those equation of the tangent line problems. We're going to see those throughout the book. All right. So that was 31. Let's take a look at a problem like 41. Now, I would suggest, even though it wasn't assigned, that you do both 41 and 42, because these are very typical exam kind of problems. I'm not going to do all the parts for 41, but we'll look at some of the parts on 41, maybe just one of the parts on 41. 41, they say, okay, f of 5 equals 1. F prime of 5 equals 6. G of 5 equals -3. And finally, G prime of 5 equals +2. So these are given to us. And I'll take a look at part C. I'll do part C. They want us to find G divided by F prime of 5. That means find the derivative of G divided by F, then plug in 5. Now, we don't know the derivative of G divided by F. We don't have a function for G, nor do we have a function for F, but we do have the quotient. And the quotient rule says, if I want the derivative of G divided by F, I know how to find that, right? The quotient rule says, if you want to find the derivative, and see what they've done here, they put the G on the top and the F on the bottom to try to trick us. But we know what to do. We put the denominator there and we square it. We put the denominator there. That's our first step for the quotient rule. There's going to be a minus right here. Who goes here? G prime, right? Numerator's derivative goes right there. Minus, we write the numerator there. We write the derivative of the denominator right there. Now they want us to evaluate this at 5. That's not times 5, right? That's a function. That's at 5. Well, we know f at 5. It's given to us right here. F at 5 is 1. We know G prime at 5. G prime at 5 is 2. So that goes there. Minus G at 5 is -3. So we plug that in. F prime at 5 is 6. So we plug that in. And now the denominator is going to be F at 5. F at 5 is 1. And we have to make sure we square that. And now we just have arithmetic. 1 times 2 is 2. Negative times negative is positive. So that's plus 18. 3 times 6. And on the bottom, we have 1 squared, which is 1. So our answer is 20. All right, so now you can try A and B. Okay. So what do we got on the other page? Let's take a look at 52, right? 52, we'll skip down to 52. 52 says, on what interval is the function? So on 52, they give us a function, f of x equals x squared e to the x. Well, that's incorrect. X squared e to the x. And they ask us, when is it concave down? Now we got it, right? We have to translate that. Concave down means f double prime of x less than 0. When is the second derivative negative? Now the only way we can get to the second derivative is by first taking the first derivative, right? That's our initial step, to take the first derivative. This is a product. We take the derivative of x squared, 2x, We multiply by my second function. In this case, that's e to the x. Plus, we leave the first function alone. That's f. We multiply by the derivative of e to the x. That's e to the x. Now, if we wanted to, right, that's our first derivative. But the first derivative tells us about increasing and decreasing. They didn't ask us about increasing and decreasing. They asked us about concavity. So we need the second derivative. So how are we going to get the second derivative? We're going to take the derivative of this times this, and we'll take the derivative of this times this. We'll just do the product rule again. So this is going to be my f, this is going to be my g. The derivative of 2x is going to be 2. I copy that function. Plus, don't forget the other half of the product rule. I keep the 2x. I take the derivative of e to the x. That turns out to be e to the x. So we took the derivative of this right here, right? Plus, now we've got to take the derivative of this product. So the derivative of x squared, 2x. I leave my e to the x. Plus, I leave my x squared, right? I take the derivative of e to the x. And what do I have? So we took the derivative of this over here. Well, do we have any like terms, right? This is 2. Well, let's factor out an e to the x and see what happens, right? If we take out an e to the x, we get a 2 plus 2x plus 2x plus x squared. All right. We can collect like terms here. This is going to be e to the x. That's going to be a 2. That's going to be 4 x's. And that's x squared. Now we're asked, when is this concave down? In other words, we're being asked, when is that product less than 0? When is it negative, right? When is it negative? And it's a product. It's that function times that function. We know when those are going to be negative. They're going to be negative if the first function's negative and the second function's positive. That equals a negative, right? Negative times positive. Or if the first function's positive and the second function is negative, that's going to equal another negative. Now, they were nice to us in this problem because our first function is e to the x. Well, we know what the graph of e to the x looks like. This is the graph of y equals e to the x. This is always positive. So this case, we don't even have to worry about because our first function is always positive. The next question then, is it ever the case that 2 plus 4x plus x squared is negative? We have to ask ourselves that. Can x squared plus 4x plus 2 be negative? Right? That's what we're asking ourselves. And so how are we going to answer that? Well, one way is to graph that parabola and see when it's below the x-axis. This is clearly a parabola that opens up, right? That's a right there. A is greater than 0, so it opens up. We can find the x-intercepts. We know how to find the x-intercepts. X-intercepts are solutions. If you don't like that word, we can say roots. Now, x squared plus 4x plus 2 does not factor, but we can use the quadratic formula, right? X equals negative b plus or minus the square root. B squared is going to be 16, right? Minus 4 times a, which is 1, times c, which is 2, all divided by, so negative b plus or minus b squared minus 4ac all over 2a. Now, if we simplify this, right, what do we get? We get negative 4 plus or minus. This is 16 minus 8, so that's the square root of 8, all divided by 2. So that's going to be negative 4 there's a perfect square in there, so that's plus or minus 2 root 2, all divided by 2. Now that's going to equal, because we can cancel 2's, so we're going to get negative 2, right? Because 2 goes into 2 twice, 2 goes into 2 once, negative 2 plus or minus root 2. So what do we know here? Remember, don't lose the forest for the trees. I mean, we're doing an algebra 2 finding solutions using the quadratic formula step here, but we're trying to figure out when this is negative. It's a parabola. We know it opens up, right? We know it opens up, but does it open up like this? Because if it does, then this part of the parabola right here is negative. It's below the x-axis. So between this number and this number, this would be negative. And if it is negative, then we're going to get a negative product and we're going to be concave down. There's a lot of logic going into this problem, that we're putting together multiple ideas here, right? I mean, it is number 52. It's not number 3. So if we look at these numbers, right? If we look at these numbers, we have negative 2 plus or minus root 2. Well, negative 2 plus root 2 is going to be negative 2 is negative 2. Root 2 is 1.4. So negative 2 plus root 2 is going to be here. It's going to be negative because root 2 is smaller than 2. Negative 2 minus root 2 is going to be over here. Right? So our parabola opens like this. This value right here, right? This value is negative 2 plus root 2, and this value is negative 2 minus root 2. So our parabola, our function, is negative between those two numbers. That is one of the factors of our second derivative. The other factor is positive. So negative, positive, that means negative. So our function is concave down on the interval negative 2 minus root 2 to negative 2 plus root 2. All right, that completes the exercises that I'm going to work on for section 3.2.